Welcome everybody to the Daily Space Weather. Welcome spaced out viewers, welcome friends, foes, science noobs, and science pros. Today we'll be talking about our October contest announced, Electron Flux, and earthquake risk remains high despite seeing a 6.7 magnitude quake strike near Tonga. We'll get to it. First we're looking at the sun in 94 angstroms. And if you're wondering if those little sprites are spaceships, well, you'll have to consult a different YouTube channel, one that has their head deep, deep up their posterior region. What I'm talking about is, oh my God, there's sprites. Look, there's one. Holy crap, it must be a spaceship. It can't be some plasma. By the way, you'll only find it in this wavelength. And yeah, we try not to provide nonsense. We don't see any sunspots, by the way. We see very high levels of electron flux and a subsiding solar wind stream. So coronal hole wind stream ramping down here. Here's a 304 angstroms view of that active region, otherwise known as a plage. And there is still a significant plasma filament right in this area. I'm sure you can probably see that. Kind of draped over the northern hemisphere there. I'll let that play through another time for you. And here's the 171 angstroms view. So yeah, coronal hole wind stream subsiding now, and earthquake risk remains very high. We're seeing a drought in earthquakes. Don't be surprised to see a large one. The 10.7 centimeter radio flux is still at 73 solar flux units. There's the graph of approximately 3 years. And about 3 years ago, we were all the way up above 90. And you can see the KP index, a global measurement of geomagnetism, has calmed down, having reached geomagnetic unrest briefly yesterday for about 6 hours, now down to a KP of 2. We don't see any solar flares. Again, no sunspots visible on the solar disk when I did show prep, although you never know when one could pop up. No major proton events. Here's the real-time solar wind. And here you can see recently we saw a little ramp down here in the solar wind density, now around 5.5 protons per cubic centimeter. Solar wind speed down consistently over the past 24, now around 531. We'll say around 520 kilometers a second. You can see this temperature suddenly dropping off to another indication that the coronal hole wind stream is ending, and it could end promptly with a big ramp down in the density and the solar wind speed. Here's what's going on in the magnetosphere according to the Space Weather Modeling Framework. This is 4 hours of data, courtesy of University of Michigan. And we show 4 hours of the geospace movies daily on the Daily Space Weather. This is showing you the magnetohydrodynamic pressure in nanopascals. Next, we'll look at ground magnetic perturbations right after we look at U.S. power grid induction, and you can see a big-time decrease in the amount of induction in the U.S. power grid. And the hottest spots we typically see are in, indeed, northern North Dakota and northern Minnesota. Quite more calm than it was during all those geomagnetic storm conditions that we saw. It was a major coronal hole wind stream, lasting a few days there. That coronal hole was associated with the north solar polar fields as well. Anyway, here's 4 hours of ground magnetic perturbations during this polar excursion. If you weren't aware, we've got two north poles, one over Canada, one over Siberia, and the south pole has left the Antarctic continent and crept into the Indian Ocean. Here's the GOES magnetometer data, 3 days worth, and the current sheet polarity boundary crossing probably happened twice, possibly snapping back and forth. It's tough for the GOES magnetometer to tell because this is noon and this is midnight local time for the satellite. So when it's on the other side of the planet, it gets lower readings. Now we're seeing quite high readings here, an indication that we are solidly in the South Pole oriented current sheet. And here you can see that snap across on the Gong 2 data. It's the top view ecliptic plane field plot. And this data is about 2 hours old, which is fairly average for this set of data. As far as forecasts for the GOES magnetometer, we're going to see some spiky readings there. Let me show you what I mean. There's the last frame, and we're going to see a big increase in the GOES magnetometer readings, as these are more direct potential field force lines as soon as we get out of this plasma-rich region here. So expect to see some spikiness once again in the GOES magnetometer. In the next 6 to 10 hours or so, we should see some higher GOES magnetometer readings. Here's the line of sight field plot. And it took us a long time to be able to tie the data together, folks. It's part of the reason why we do the daily space weather videos. We're interested in the physics of how all of these things relate, since all things matter. Anyway, this one shows you the B field in blue. No major perturbations in the B field right now. Here's the coronal magnetic field plot. And it's showing you closed potential field force lines in pink, coronal hole potential field force lines in purple, and open potential field force lines in black. And we should see this. We should see some motion in this by tomorrow's daily space weather video. So don't forget to tune in. We do it daily. Today's Smash Lights is highly truncated because I'm going to vanish. So today's Smash Lights isn't going to be a separate video. We're just going to say, hey, don't forget to press like and subscribe over on YouTube. Press the notification bell. And we're wondering if our view count will suddenly jump up in the year 2021. We're also on BitChute. We've been bleeding subscribers over there as well. So check us out, bitchute.com/smashamash. You can find exclusive content, such as our video from 6 months ago about hydroxychloroquine. Yeah. And we do stream live most days to Twitch. It's twitch.tv/smashamash. We're not really going to be too concerned about COVID today, although we do have a forum section on it. So maybe go have a read over there, smashamash.com/forum. In the free-for-all section is a 31-page document going all the way back to January 23rd. If you'd like to see what we were posting on April 30th, researchers crack the code, the genetic code, using AI, and they identify the origin, allegedly. I won't get into it. smashamash.com/forum. By the way, consider becoming a patron if you haven't. Our patrons are the true source of funding for the content. It's patreon.com/smashamash, and we update our credit crawl on the 2nd of every month, because you gotta pay to play if you'd like to see your name in lights. Well, patreon.com/smashamash. You'll also receive benefits such as receiving alerts. Keep in mind, folks, that the $1 and $2 tiers, intro and intro squared tier, are going away by the end of the year, because $1 and $2 is not significant enough for us to post for you. And we're going to talk a little bit about cosmology today. We're going to do a cosmology segment. It's going to be pretty basic, as there's only really one thing I want to talk about. It's cosmic rays. Now, cosmic rays influence Earth's atmosphere directly and basically instantly. Yes, energy from space. All your weather comes from space, largely. More or less. I mean, Earth comes from space, so in any case, here are the data sets from the Apatity Neutron Monitor, and it's pretty flat here over the past month. Small uptick at Apatity, actually, but it's about where it was a month ago. And here's Barentsburg, a slight downtick there over the past 30 days. Let's go farther south to Athens, Greece. Here's 30 days of Athens, quite flat over the past month. Next, we'll go even farther south to Mexico City before we go back north to Oulu, Finland. So there's Mexico City flat on the past 30 days. And here's Oulu and DOMC Antarctica. There's Oulu, Finland. Downtick over the past 30 days. And there's DOMC, downtick there over the past 30 days. Also, if you want to monitor cosmic rays yourself, just look up links to cosmic ray data, network of cosmic ray stations. Follow it yourself. Don't take my word for it. And let's talk about the October contest. Now, the theme on the shirt will be a cosmology theme. I've already got ideas about what it'll be. We're down to 2 ideas now. So we've decided to give away a free shirt for October. We'll roll out a new design this month, and we'll give one away to the lucky contest winner. We're going to use a quantum random number generator, which we'll roll out later as well, and submissions on this very thread to determine the winner. So the rules are simple. You must post here on this thread, which means you'd have to sign up for the forum. Simply post here with the words, "Sign me up," and by Halloween, probably before that, we'll announce the winner. In the meantime, we'll highlight this forum thread daily. We'll also announce the deadline, and the design will likely roll out a few days from now. Once we send out the first shirt, then we'll start selling that shirt in one of our Teespring stores as well. You can link to all of that stuff at smAsho.com. This way, the contest winner will have the first shirt with the design in the world. The contest is free to enter. Void where prohibited. Here ends another Smash Light. Let's get back to data. The electron flux is at the highest levels we've seen in a year, having not been there since mid-October of last year. And our patrons were already aware of this. If you weren't, again, it's patreon.com/smashomash. Charging hazards primarily south of the equator here, as a result of the massive levels of electron flux, which are indeed forecasted to go even higher. And I would agree with this forecast. So we're getting into some of the highest levels of electron flux in over a year here, probably. There's the 3-day chart, and that reached approximately 30 times the warning threshold, nearly 30,000 pulse flux units. If you're around the equator at noon and you're using a GPS, expect to see some major errors. Here's a visualization of the entire air column from the thermosphere down to where your handset would be located in your hand. And it really doesn't look like that high of levels there, but that's just the way the visualization works. And here's just one slice of the atmosphere. It's just the ionosphere layer, which is looking fairly normal here. And we used to show only 6 hours of this. Now we're showing a full day, to give folks a little better idea of the way the ionosphere charges and discharges. Like sands through the hourglass of time, these are the rotations of the planet. There's where things are at 8:15 Universal Time, looking normal to me. I like to know what's going on above my head, so I use in-the-sky.org. I face my star chart to the east, and check it out. Venus is practically overlapping Regulus right now. Oh my God. If you're up before dawn, you may see the third brightest object, my favorite planet, Venus, which in our Scrying with Smash series, I've forecasted to switch places with Mars. Yeah, they're going to switch places, folks. I didn't even explain why. Maybe it's because life is more likely to exist on Venus than Mars. I don't know why that would be so surprising. Happy harvest moon, by the way. There's where things will be in the solar system in 1 week. And thanks, Mary, for commenting on the Jupiter-Saturn conjunction, which will occur right near the solstice on December 21st, I'm told. Largest earthquake of the past 24 hours was this 6.7 northeast of Tonga, in between Fiji and Alofi, near the Tongan Trench. Yes, yes. I wouldn't allow that to relax my earthquake risk because, well, we're still seeing a major, major drought of magnitude 7, magnitude 8, and magnitude 9 earthquakes, folks. So here we could see a deep quake at the Fiji region, just to the west-southwest of that 6.7 magnitude quake. That 4.4 magnitude tremor came in at a 580 kilometer depth. Very deep quake. And we're just going to scroll up the list here, as there are tons of things on the list, including some earthquakes in California. Quite a lot of them, actually. So lots of shaking going on there. A 4.9 magnitude quake struck Westmoreland. Please leave us a comment if you felt the shaking. If you've got an eyewitness report or a video, hit me up. We may cover it. So here's a 6.4 at Tonga. Must have been a foreshock. So a small uptick here in seismicity. Still nothing over a 7 magnitude. And again, we are seeing a drought of 7, 8, and 9 magnitude quakes. Here's a deep quake at Bolivia. And let me take the opportunity to draw in the place where I would be on alert. That was a pretty bad drawing. Let me try that again. Western South America, the Cascadia Zone, and Oceania up to Japan. If you're in those areas, please have an earthquake plan. Have a bug-out bag. Know which building facades may collapse, and perhaps you'll be able to be an asset, not a liability, in the event of a disaster. That 4.1 magnitude quake in Bolivia coming in at 286 kilometers. Here's another deep quake very nearby at Argentina. Must be near the Argentina-Bolivia border. And let's go to volcanoes at volcanodiscovery.com. Etna back on the list with a dark cloud growing above summit. Dacono exploding, 7,000-foot ash plume there. Popocatépetl exploding, 19,000-foot ash plume there. Sangay exploding, 19,000-foot ash plume there. Volcanic ash emissions have dissipated at Revenador, and we're seeing continuous emissions at Sabancaya down there in Peru. Please do not attempt to pole vault the caldera. Next, looking at the jet streams. There are the jet streams of the Western world. And maybe you're going to hear stories about how, OMG, Greenland is melting. Greenland is melting. It's because warm air is being thrust northward with extreme meridional jet stream flow, where the jet streams flow north and south instead of flowing west to east, the normal behavior of the jet streams. Here are the jets of the east. And Australia's got a doubled up jet stream and a convergence over the eastern portion of the country there. Here are water vapor maps for Europe and Africa. Shout out to our viewers from those areas. Let me just check the life of the stream here. And thanks for leaving a comment. Be stoic. We're glad to hear that your internet is back here at the Smash News Network. Here are the water vapor maps for the Far East and Oceania. Shout out to our viewers from those areas. Here's a water vapor map for the Americas. And we see incredible lightning once again in the Caribbean. We'll get to it in a minute. First, pressure. And here are where pressure cells are located. We're going to let this advance into the GFS forecast, courtesy of windy.com, who has a great mobile app, by the way. And I'm not paid to say that yet. I do it at personal risk and massive expense. Here's where we expect things to be at 12 noon tomorrow. That major low pressure system still south of Alaska. Shout out once again to Brett. And here's lightningmaps.org, and talk about some major lightning. 2 days in a row we covered major lightning here in the Caribbean. Enough to put up the NASA GOES lightning mapper. It's quite a good visualization there. You can see the way the storms line up with clouds. Great visualization there, courtesy of the GOES 16 lightning mapper. And we've made sure that you can see the time and date stamps up there. Some major cloud nucleation happening here around West Virginia and Kentucky also showing up. You can see right there. Some sudden cloud nucleation happening. And let's move on. to the U.S. Doppler radar map. Nothing too exciting happening there. Maybe some good surf on the Atlantic coast of Florida, though. A bunch of low clouds here over the Gulf of Mexico. These are the kind of clouds that form as a result of cosmic ray flux, if you weren't aware. Clouds from about 12,000 feet on down. And I can tell just by looking at those that those are low clouds there. You can actually see these higher clouds here and this system kind of moving over the top of this system. These are the low clouds I'm talking about. You've got two different altitudes working there. And let's look at the water vapor map. We'll zoom in on that same region, the Gulf of Mexico. And let's look at the convergence over central Pennsylvania as we have the jet stream dipping down and forcing some colder air to the east. And if you're flying across those areas like this, expect to see some turbulence there as you've got dry massive air, less massive air, and more dry massive air. And hey, Smash team, thanks for tuning in to the Smash News Network. We've got bonus features. By the way, our Teespring products are 100% guaranteed. It's 30-day, 100% money-back satisfaction guarantee. Perhaps consider getting yourself a Mansa shirt if you'd like to make America not suck again. Newsflash, it's up to you. America's not going to just stop sucking unless everybody puts forth some effort. Check out our merch. You can link to it all at smashomash.org, which will redirect you to smashomash.com. If you haven't been there, check it out and visit our links. Also, we've got an affiliate link. We're going to be adding a product to it today. Shout out to Smash staff. Remember the mustard we talked about yesterday? If you haven't checked out the affiliate link, it's smashomash.com/affiliate. We've got supplements, we've got PPE, we've got shugu, we've got mashed potatoes. My bio bug out bag. Garnier Fructis products in case anybody's going to be standing behind you sniffing your hair in the next month. The mouse that I use to make this very video is available, as well as if you need some two-stroke mix oil, we've got it. smashomash.com/affiliate. And I would like to thank everybody for flying American Smashways. I, your pilot, Dan, a.k.a. Smashomash, will have to vanish. And remind you to please keep your head and arms inside the Smash plane at all times. As we've got bonus features, it's a 48-hour SDO video and 335 angstroms, one of the many ionized UV emission spectra states of iron. Yes, it's an ironclad channel. That's why we never miss a day or a trick. Here's a colorized magnetogram showing you 0 sunspots. There's that large plage, not to be confused with large Marge. And you see there are no sunspots, no dark umbral cores here. Nothing resembling a sunspot. Here's a 335 angstroms view. I like the soothing blue tones. Anyway, thanks again for tuning in, everybody. Remember, stare at the sun, attempt to understand the physics. Don't drink, and if you do, don't drive. Certainly don't drive. I don't want to see you out there. No matter how much I like you. Now, don't take that too seriously. In any case, may that solar wind be at your back and that covidiously absent from your universe.